This is an example from Chapter 6 on how to solve a problem related to enthalpy diagrams. Please take a few minutes to read the problem, understand the questions, understand the equations, and then suggest a plan on how you will solve this problem. To solve this problem, we are going to need to draw an enthalpy diagram. In order to make this drawing, we want to have to identify dissociation reactions and calculate their total delta H, or delta H of dissociation. Next, we will need to identify the formation reactions and calculate their total delta H, or delta H formation. We will use this information to define the delta H of the reaction, the delta H of dissociation, and the delta H of formation in the diagram that we just drew. Finally, based on the relative energy of delta H dissociation and delta H formation, we will determine whether this reaction is endothermic or exothermic. So let's begin by identifying the dissociation reactions. So the problem that we have here then will consist of having CaCO3, which is a solid, that will dissociate to calcium solid plus carbon solid, which is graphite, plus 3/2 of oxygen in the gas phase. We are going to use a coefficient of 1 in this particular example, as we have it here. The delta H for this reaction which is a delta H of dissociation, is going to be equal to minus 1206.9 kilojoules, which corresponds to half of the value that was given in the problem. The second component of this is the formation reactions. So for the formation reactions, we are going to have calcium plus 1/2 of oxygen molecules in the gas phase to form calcium oxide, which is a solid. The second reaction of formation will correspond to carbon solid, graphite in this case, plus oxygen in the gas phase to yield CO2 in the gas phase. The delta H of formation for the first reaction corresponds to minus 635.1 kilojoules. The delta H of formation for the second reaction corresponds to minus 393.5 kilojoules. So we know then that if we add these two, the delta H of formation total is going to be equal to minus 1029 kilojoules. Once we have this information, we can start drawing the diagram. So in the enthalpy diagram, we are going to define the y-axis as energy, or delta H, and the x-axis will have the different reactions that are happening. We are also going to try to define the elemental state of all the reactants that we have here. So we are going to define that in an unusual fashion because we are going to assign that as 0 delta H. And that will correspond, that elemental state will correspond then to having calcium, carbon, and 3/2 of oxygen. Now, the delta H of formation and dissociation both were negative. We know that the delta H of formation was equivalent to minus 129 kilojoules, and we are going to define this level as such over here. So a delta H of formation then will result from a transition that goes from the elemental state to this particular energy or enthalpy level here. And in this particular example, delta H of formation will correspond then to calcium oxide and CO2. We also have the delta H of dissociation. So delta H of dissociation, we determined that it has a value of 1,206.9 kilojoules, and is lower than the other one. So delta H of dissociation then corresponds to a transition that goes from the initial state to the elemental state. The delta H of dissociation also will correspond to the compound that we initially have here, which is CaCO3 in the solid phase. And this value will correspond to adding the energy, which is equivalent then to the energy going from minus 1206.9 to 0. Now, because we can compare the relative positions of dissociation here and formation, we see that the final product, which is in this case over here, will be at a higher energy than the initial reactant. Therefore, this reaction is an endothermal reaction. And the delta H of this reaction is going to be then the difference of the dissociation, minus 102.9 minus 1,206.9, which is going to correspond to 178 kilojoules. It's a positive sign because it's an endothermic reaction.